Hello, my lovelies, and welcome to our fourth video of Unit 1. For today, we're going to switch gears a little bit. Because, well, the types of problems we're working with, they're largely the same, but the form they're expressed in is going to start to look a little different. So far, we've worked almost exclusively with symbols. But sometimes, all those symbols, they make us forget that, at its core, math is about solving problems. And specifically, that humans thousands of years before us were using math to model problems they found in the world around them to make them easier to solve. So to bring some of that humanity back to the math we're doing, let's see how we can hopefully use what we've learned to do some problem solving with equations, which is the title of our fourth class of Unit 1. Now, some of the problems that we're going to be working with are really just exercises in translating. I've got stuff in English language. I want to rewrite it in math language, which actually connects really nicely to this idea that the math that we're doing, it's really just a language that we're learning how to speak. So for example, 6 times the sum of a number and 15 is negative 18, and I've asked you to find that number. Now maybe alarm bells are going off for you, maybe your hackles are up. You should hopefully know from some prior point in your mathematical journey that there are lots of words in the English language that translate really nicely to math language. So take a minute, pause the video. If you look at this sentence, what words do you see that immediately clue you into the fact that you're working with some mathematical symbol or operation? What translations here can you do? Take a second, see what you come up with, play around with it, and we'll chat. And we're chatting. I'm feeling chatty. So, 6 times the sum of a number and 15 is negative 18. Well, a couple things I hope immediately stood out to you. First of all, 6, 15, negative 18, not like symbols that I need to translate, but those are numbers I can slot into an equation. And the idea behind working with an equation here, right? There's probably some of you who found a number that worked just by trial and error. And that's amazing. But the idea here is that equations remove some of the uncertainty that just like a guess and check strategy might introduce. So we want to work with an equation. And in fact, there's a word in here that tells us we're working with an equation. What word am I talking about? Very nice, invisible person. That word is. Remember, if something is something, it's the same as, it's equivalent, it's equal to. So I've got an equal sign in this sentence. I am working with an equation. Other words that I hope jumped out, times something, that's multiplication. And then another one, of here, we've seen before. This one often tells us multiplication, but when it's next to the sum of, then no, I'm actually no longer in multiplication land. When I'm summing two things together, this is, of course, addition. The last thing I need to figure out is this a number. Do I know what that number is? No. So think strategically. What in math can I use to represent some number that I don't know yet, but I'm trying to find, an unknown that I'm looking for? Well, this is an opportunity for it if I've ever seen one. An unknown that I'm trying to solve for? Isn't that the definition of a variable? So this is going to be my variable. And you'll see here, you can be strategic about some of the choices you make. For variables, you might like x's and y's and z's. For me, I see this word number. I'm going to choose to use the variable n. You can choose whichever symbol you want. For me, number starts with n, so I'm going to choose n. Let me slot the rest of what I've got into an equation. So 6, and then I'm doing 6 times, so maybe I'll use a dot to represent my multiplication. In this case, what's being multiplied by 6? Is it just the number? I don't think so. It's the sum. So it's the number plus 15 that's being multiplied by 6. Well, how could I indicate in symbols that it's the number plus 15, that whole thing, that's being multiplied by 6? Well, If I'm doing a number plus 15, that whole thing is multiplying by 6. Well, one way to indicate that is to suggest that they're a group. In other words, let's introduce, shout it out, not that loud, parentheses. So I'm going to use some parentheses here for my n plus 15. And then I know if I do that multiplication, it should be equal to negative 18. Cool. We've got an equation. Let's solve it. Take 2 minutes. See how far you get. Let's see if we can find this value n that we're looking for. And stop. So I want to again get n by itself. So I need to ask myself, well, what's in the way? I've got a 6 and a 15. I've also got some pesky parentheses that I've added in that I need to get rid of. So one way to get rid of them is to distribute. But if I distribute that 6 to the n, I'm going to get 6n. And then if I want to get the n by itself, I'd need to divide by 6 again. Remember back from class 1, a more efficient strategy rather than distributing, let's start by dividing both sides of the equation by 6. So 6 divided by 6, these will undo each other. I'm left with just the n plus 15 on the left. Then on the right side, I have negative 18 divided by 6. Well, that's negative 3. And then one thing standing between me and n by itself is that pesky 15. Let's undo it with a negative 15. 15 minus 15, this is 0. And negative 3 minus 15, or negative 3 plus negative 15 if it helps, well, that, of course, is negative 7,000. Okay, n equals negative 18 seems to be the answer that we're looking for. How could I check? Remind me really quickly, what's the strategy to confirm that this answer will actually make my equation true? You get it? You got it? Good. Well, in this case, all I've got to do, if I take n and I substitute the value of 18 in, I should be able to confirm that this is actually the number I'm looking for. Now I've just got to check, is that left side equal to the right? We'll take care of your parentheses first. Negative 18 plus 15 is negative 3. Then I have 6 parentheses negative 3. Is that equal to negative 18? Well, 6 parentheses negative 3 means 6 times negative 3. That is indeed negative 18. So, does this make us happy? No, probably not. Nothing makes us happy. Happiness is elusive and impossible to achieve. I'm kidding, of course, but in this case, does it make us happy in the context of this problem? Yeah, it does what we want it to do. It solves our equation. It makes it true. Cool. Let's do 2 more. Just to make sure that this idea has really set in. You've got 2 in front of you. Let's read through them real quick. See what translations you can do, what words will immediately give you some symbols, and then see if you've got some equations, if you can solve them. Go ahead, and we'll be back. Hello? Are you there? I missed you. I felt so lonely. Okay, the sum of twice a number and half the number is 10. Let's find the number. So, the sum of course, is absolute value. No, it's addition. Twice a number. Well, a number, the number, that's the thing I'm looking for. There's my variable. I'm going to choose n. You can choose whatever variable you want. Twice a number. Well, if I'm twicing something, hopefully you should know that means, I'm making it a K-pop group. No, I'm multiplying it by 2. And half the number, well, that's dividing by 2. And then I know if I sum them together, so 2 times n, a simpler way to write that is 2n. If I add that to half the number, so n divided by 2, that is 10. So in other words, that sum equals 10. Cool. And then below it, the quotient of 3 more than twice a number and 7 is negative 3. The quotient of, this one I hope you've seen before as well, quotient should usually cue me into the operation division. So if I'm doing division, if I take the quotient of 10 and 5, that means I'm dividing the 10 by the 5. So the one that shows up first, that's the one that's being divided. The one that shows up afterwards, that's the one that's doing the dividing. So the one being divided is the 3 more than twice a number. Well, let's take this piece by piece. Twice a number, well, I know from above, twice a number is 2n. 3 more than twice a number, well, 3 more than 1 is 4. And how did I get there? Well, that just means that I added 3. So in the numerator, if I think of my division as a fraction, the thing being divided should be 2n, and then 3 more than 2n would be 2n plus 3. And then I've got my division here. The thing doing the division is that 7. And then when I do that division, it is -3, so this equals -3. Okay, you've got some equations. If you haven't already solved them, pause the video real quick and do it. If you have already solved them, don't pause the video and we'll do it together. 2n plus n over 2 equals 10. Alarm bells, alarm bells, alarm bells. What do you see? What don't you like? If you were like me, I see a fraction. Remind me real quick. Think back to class 1.2. What's the strategy for getting rid of an unwanted denominator? What could I do to each of my terms to eliminate that pesky division by 2? Go ahead. What do you think? 10 seconds? Talk to a partner. And by talk to a partner, I mean talk to yourself. Unless there's somebody in the room with you. Hi, person. What's up? How you doing? Okay, 2n plus n over 2. I want to get rid of that over 2. Let's get rid of division by 2 by multiplying by the least common denominator. And in this case, our only denominator is 2. So multiplying every term here by 2, well, 2 times 2n is 4n. 2 times n over 2, I'm multiplying by 2 and dividing by 2. Those undo each other, so that's just n. And then 10 times 2, well, there's 20. And from here, I should feel kind of okay about where to go. On the left, 4n plus n, those are like terms, I can combine them. That's 5n. 5n equals 20. Let's divide both sides by 5 to get our n by itself. When I do that, I find that n is equal to 20 divided by 5, which is 4. And on the bottom, 2n plus 3 over 7 equals -3. Now my strategy of reverse PEMDAS tells me I should probably see that real juicy plus 3 and want to get rid of it, but what's in the way? What's stopping me? What's even juicier? Well, I've got a fraction bar. A fraction bar is an example of a group. I can't do the stuff in the numerator until the denominator goes away. Well, to get rid of that pesky divide by 7, let's multiply both sides by 7. So I'm going to do times 7 on the left. Our 7 on the top, 7 on the bottom. Those go away. I've got 2n plus 3 left over. And then I've got -3 times 7 on the right. Well, that's -21. To get n by itself, here my reverse order of operations will not lead me astray. Let's do our -3 first. When I do that, 3 minus 3, these undo each other. I've got 2n equals -21 minus 3. I'm making that negative even more negative to get to -24. And then the last thing standing between me and n by itself, let's divide both sides by 2. On the left, 2 over 2, those cancel each other out. And I'm left with n equals -24 divided by 2, which is, of course, 19 billion. Okay, so on the top, we've got n equals 4, n equals -12 on the bottom. If you don't believe me, and maybe you shouldn't, right? You should actively interrogate all of the choices that you're making rather than blindly following and consuming passively. Check your work. Let's plug these back in and make sure that they make sense. I wrote these problems and I know the answers, so I'm pretty sure we're good. But if you don't believe me, feel free to verify on your own. Cool. What's nice about this language is that now we can ask some really cool and really creative questions. So look at this, friend. The sum of 3 consecutive odd numbers is 57. And I'm asking you, what are those 3 numbers? Well, some context here that's important. To make sense of this, I need to know, what does it mean for numbers to be consecutive? And what does it mean to work with odd numbers? So take a second. What does it mean if 2 things are consecutive? And then if I'm thinking about odd numbers that consecutive, what might 3 of those look like? Take a second, pause the video, see what you come up with. Okay, so consecutive if you have not seen that word before, things that are consecutive are right next to each other. So I want 3 consecutive odd numbers. So for example, maybe I'll take 5, next odd number is 7, and the next odd number is 9. Cool. Now I want to think, because I'm trying to turn this into an equation, I need to know something about the anatomy of these numbers. How are they connected algebraically to each other? In other words, like, what could I do to get from 5 to 7, and from 7 to 9? Take 5 seconds. What do you think you could do? What's the easiest choice you could make here to increase from 5 to 7 or from 7 to 9? 5, 4, 3, 2, 1, and stop. To get from 5 to 7, well, the easiest choice I could make, there are lots of ways I could do it. The easiest, maybe the most straightforward, if I add 2 from 5, I should get 7. And if I add 2 from 7, I should get to 9. So now, that's with a number that I know, but I don't know what my 3 numbers are. So here's where my variable is going to come in. Let's say maybe that when I'm choosing my variables, maybe I use the variable to represent the first number. So maybe I'll say n is my first number. If n is the first of those consecutive odd numbers, what would I need to do to the n to get the second of those odd numbers? And the same thing for the third. Pause the video, take a second. What would the second number be if the first number is n? And the same thing with the third. Okay, well, to get from the first to the second, all I need to do is add 2. So if n is the first number, then n plus 2 should be the second. And if I add another 2 to n plus 2, well, 2 plus 2, I have to add 4 to the first one. Okay, and now I know from the structure of this sentence that the sum, in other words, if I add them all together, then n plus my second n plus 2, plus my third one n plus 4, adding those all together should get me to 57. Okay, so maybe you've built this equation and that's amazing. Maybe you haven't built this equation and that's amazing. But let's try and solve it now. Give yourself some time if you haven't already. Let's see if we can find the value of n that makes this equation true. And return to me. Come back. I missed you. So n plus 2 plus n plus 4 equals 57. Well, think strategically. N. Those are like terms. So how many n's do I have in total? Well, I can put them together. I've got 3 n's plus, well, I have 2 plus 4. 2 plus 4 is, of course, 17. And then that's equal to my 57. So now I need to get n by itself, and from here I should be home free. Let's subtract 6 from both sides first, a reverse order of operations. On the left, they undo each other. On the right, 57 minus 6 becomes 51. And then the last thing standing between me and n by itself, I'll divide both sides by 3. On the left, they undo each other. And on the right, n equals 51 divided by 3, which I believe is 17. Now, am I done? I don't know, you tell me. Am I done here? No, right? I don't want just the first number. I was asked what are all 3 of those numbers. So n was the first one. N was the 17. So the next one should be n plus 2. And that's going to be 17 plus 2, which is 19. And then the next one, I add another 2 to get to my third one. Well, 19 plus 2, my last number should be 21. Now, if you don't believe me, take out a calculator, do some mental math. 17 plus 19 plus 21, does that equal 57? It turns out that it should. Alrighty, so there's the idea. Let's do another one, just to make sure it really sets in. So let's say that the sum of 3 consecutive even numbers this time is negative 264. What are the 3 numbers? So the only question that you have to ask yourself is, would anything change algebraically about the structure of the relationship between consecutive even numbers? So take like 6, 8, and 10. right? Would adding those, or thinking about how I get from one to the other, does the structure of those change? And if it does, figure out how it does. If it doesn't, then use your structure from above and see what kind of equation you can write. Alrighty, we're done. So, I want to figure out, does my structure change? Well, to get from 6 to 8 to 10, right? 6 to 8, that's plus 2. 8 to 10, that's plus 2. My structure still works. So let's say, borrowing that same idea from above, maybe I'll use n to represent my first of my even numbers. My second one would be 2 more than that n. And then, why did I write first twice? And then my third number, well, that would be n plus 4. And I know that if I sum all of them together, I should get, in this case, a negative number of negative 264. Okay, and from here again, I'm going to add my like terms. N plus n is 3n. And then I've got 2 plus 4, which is 6. That equals negative 264. Again, same idea here. Get n by itself is my end goal. Subtract 6 from both sides to undo our positive 6. 3n is going to equal negative 264 minus 6. Well, 264 plus 6 is 270. So it's negative 270. Divide both sides by 3 to isolate our n. These guys go away. And 3 goes into 27 9 times, so 3 would go into 270 90 times. So in this case, n equals negative 90 should be our first number. To get our second number, again, I need all 3. I need to add 2 to negative 90. Well, negative 90 plus 2 is negative 88. And then my next one, I'm going to add 2 to negative 88 to get negative 86. Okay, again, add them all up, check and make sure. This should sum to negative 264. Okay, so that's cool and all. But I know what you're thinking. First of all, you're thinking, this video is really long. And it is, I promise. We're almost done, right? Word problems take a little bit longer to talk through, I apologize. But you're also thinking, and perhaps more importantly, Mr. Vallel, you promised me real human problems. I haven't seen anything real or anything human. I want to do some actual word problems. And listen, who am I to stand in the way of your heart's deepest desires? So because it means so much to you and because you asked so very nicely, just this once I'll be nice. Me? Nice? Shocking. I know, don't go getting used to it. Let's quickly take a look at this friend. And we're not going to solve it, we're just going to look just a quick gander. When he's not teaching Algebra 1, Mr. Vallel has a side hustle making beats for SoundCloud rappers. To produce a track, he charges a flat fee of $100, plus an extra charge of $75 for each minute the song lasts. If Mr. Vallel raked in $400 for his most recent commission, how long was the track that he made? Now listen, is this problem a little silly? No, absolutely not. This is a very real thing that I definitely do in my free time. But is it also something I could think about representing in symbols? For sure. So, while I won't take this opportunity to plug my SoundCloud, what I will do is take it to ask you to start thinking about how. How would you actually go about turning this from words into symbols? And the hint that I'll give you is that there's a bunch of fluff here. There is some stuff that's useful for establishing context that isn't particularly helpful, strictly necessary for solving an equation. So your task, what I'd like you to do between today and your next class, look through this, try and figure out, how can I trim this down to its meat and bones, to the stuff that's going to be important for me in writing an equation. Okay, my dears, thank you for bearing with me. Take care. Be good, have a lovely